Section 2.1 Rectangular Coordinates and Graph. Order pairs. We use the parenthesis with the x, y to represent the coordinate. Let's look at the rectangular coordinate system. The horizontal. This is just like your number 9, and we call this is the x-axis. And then we do have the vertical line here. This is called the y-axis. And we call this as a rectangular coordinate system. And for the first part here, we call this is going to be our quadrant 1. This one, quadrant 2, quadrant 3, and quadrant 4. Okay, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. For example, let's say this point on my x-axis, that will be your A. Okay, and then when I draw the horizontal line here, we call this is going to be B. We do have a point here. We call this as the point P with the coordinate of x equal to A with the coordinate of y that is equal to P. We call this as my order pair. And this point that will be on your quadrant 2. Okay, right? Now we're going to introduce the distance formula. Using the coordinates of order pairs, we can find the distance between any 2 points in a plane. So I do have a 2 order pairs. One is a P, -4 and 3. -4 talking about on x-axis, 1, 2, 3, 4. -4. And y-axis will be 1, 2, 3. Okay, so we do have this point. And then we do have a R, the order pairs of R. We do have an 8. So starting from the 0 here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have an 8 here. And then y will be equal to -2. So 0, -1, -2. So we have this point here. Now we want to find out what is the distance formula. First, I'm going to draw the horizontal line starting from the P until here. Okay, and when I draw the vertical line, it's going to be hitting the order pairs of R. So first, we call this as the coordinate Q. Okay, with x equal to x and y equal to 3. Now, let's try to find the distance of PQ. Okay, the distance of P to Q. So how can we find this horizontal distance? We're gonna look at the x-axis. We have an 8 here, we have a -4. So that will be 8 minus -4. And then we put the absolute value here because distance is always positive. And then we calculate it, we find it, the distance between PQ will be 12. So I put the 12 here. Now, I'm gonna draw a vertical line from the Q to the R. Okay, and then I want to find out the distance between Q and R here. So this time we're gonna look at the y-axis. Same idea that the distance between Q and R will be 3 minus -2 and with the absolute value. That will be equal to 5. So this is gonna be 5. Since this is a white triangle, we could apply the Pythagorean theorem. Find out the length of the hypotenuse. Okay, so that will be a squared plus b squared, square root equal to c. We calculate it, we find it out, the distance between P and R will be 13. Okay, now we're gonna combine everything together. We do have a distance formula. When we have a 2 points, 2 order pairs, x1, y1, and the R, x2, y2. And we want to find the distance between P and R. Okay, that will be our distance formula. x2 minus x1 take square plus y2 minus y1 take square. Okay, let's try to do this example. I want you guys to try plug in the x2, x1, y2, y1 to find out the distance. And let me write it down. this guy, I consider this is my x1, this is gonna be my y1. This is gonna be my x2, this is gonna be my y2. Try, plug it in. Okay, check your work. You should get square root of 194. Okay, that will be the distance between P and Q. At the points R, S, and T, the vertex of a white triangle. Okay, I want to know, does it form it like white triangle? How can we work on this one? If we could find out the distance between TS, TR, and RS, and then we can use the Pythagorean theorem to determine if this is a white triangle. Okay, so first, let's find out the distance between RS here. Okay, so I showed you the first one. So that will be my x2, y2. This is gonna be my x1, y1. Okay, it doesn't matter. You could call this as x1, y1. This is gonna be x2 of y2. Okay, because you're gonna take square, the negative is gonna be goes away. Okay, and then I find it out. My distance between R and S will be square root of 34. Okay, I have a square root of 34 here. Now, your turn. Try to plug it in. Find out the distance of RT and the distance of ST. Okay, check your work, the RT. You should get square root of 41. And then the distance of ST, you should get square root of 85. Now, we want to determine if this is a white triangle. Okay, so we're gonna apply the Pythagorean theorem. So the longest size is gonna be square root of 85, which is gonna be our C. Okay, and this is gonna be your A, and this is gonna be your B. So let's plug it in. A squared plus B squared equal to C squared. Simplify it. Oh, this is a false statement, right? If this is a false statement, that means the triangle formed by the 3 points is not a white triangle. Okay, collinear points. We can tell if 3 points are collinear, that is, if they lie on a straight line using a similar procedure. So think about it. I do have these 3 points here, P, Q, R. How do I know if these 3 points are collinear? Collinear means I could draw a straight line here to join 3 points together. Okay, what can we do? 3 points are collinear if the sum of the distance between 2 pairs of the points is equal to the distance between the remaining parts of the points. So that means I could find out the distance between PQ and then find out the distance between QR. If you add it up, that will be equal to PR. So we could say that these 3 points are collinear. Okay? Let's try to work on this example. So first, find out the distance of PQ, distance of QR, and also the distance of PR. So plug it in. You should get square root of 8 for PQ. And then find out the QR. You should get square root of 128. I simplify it, you're gonna get x square root of 2. Last one, the PR. Plug it in. You're gonna get 10 square root of 2. Okay, now let's plug it into this equation. And then 2 square root 2 plus 8 square root 2, that is equal to 10 square root of 2. So we say the points are collinear. Okay, you could join a straight line with these 3 points together. Okay, another one, midpoint formula. The coordinates of the midpoint M of the line segment with the endpoints P and Q are given by the following. So I just want to find the midpoints, okay, between P and Q. And this is gonna be the formula, x1 plus x2 divided by 2. That's the coordinate of x. And then y1 plus y2 divided by 2. That's the coordinate of y. Okay, let's try. Use the midpoint formula. So this is going to be x1, y1, x2, y2. So try, plug it in. Okay, check your work. You should get negative 9 over 2 and 4. That will be the midpoint between these 2 points. Okay, B, find the coordinates of the other endpoint Q of a segment with one endpoint P and the midpoint. This time they give you one endpoint and the midpoint, and then you want to find out another endpoint of Q here. So first, we're gonna let x, y be the coordinates of Q. And then we do have a midpoint formula. Alright, so x plus x over 2, that's equal to the midpoint of 4. And then negative 20 plus y divided by 2, that's equal to negative 4 here. Okay? We're gonna solve for the x and the y here. So you're gonna times 2 for both sides and then subtract x. You're gonna get x equal to 0. This one times 2 for both sides, you're gonna get negative 20 plus y equal to negative x. And then add 20 for both sides. So the coordinates of Q will be 0 and 12. Okay, and then graphing an equation by point plotting. If I give you guys an equation, it can be the linear equation or quadratic equations. So how can you graphing the equation? First, we're gonna find the intercept. You can find the x-intercept and the y-intercept. And then find as many additional ordered pairs as needed. Plot the ordered pairs from the step 1 and 2, and then join the points from the step 3 with the smooth line or curve. Okay, let's try to do it with the example here. First, I want you guys to find out the x-intercept and y-intercept. Remember how to find the x-intercept? If you want to find the x-intercept, you're gonna plug in y equal to 0. Okay, and then you're gonna solve for your x. Same idea. If you want to find the y-intercept, you're gonna plug in x equal to 0. Okay, x equal to 0, then y is gonna be equal to 5. So we do have two intercepts, x-intercept and the y-intercept. Now, we try to get more ordered pairs. You could make up one of the variable. You could make up the x or you could make up the y. Okay, doesn't matter what numbers you're gonna plug it in. If you want to get more, just try to make up more. So easier way here, I'm gonna put x equal to 1, and then I'm gonna solve for my y here. Plug in x equal to 1. So negative 2 plus 5, which is gonna be equal to 3. So I have a one more order pairs. So including the x and y intercept, I do have a 1, 2, and 3. And actually, this is a linear equation. We only need 3 order pairs to graph this equation. Okay, we already have a 3 order pairs. So plot and connect the 5 points together. Actually, we only have a 3 points. Join it all together. Write down the name of the equation. Okay, one more time. For the linear equation, you only need like 3 order pairs. Okay, next one. Graph the equation y equal to x squared minus 4. Okay, this is not the linear equation. I could see this is a quadratic equation. If you remember that quadratic equation is going to be the parabola. So either looks like the U shape upward or the U shape downward. Okay, so I could just make up a whole bunch of the point for the x and then plug into the equation, find out what is your y. For example, I do have an x equal to negative 2. I'm gonna plug it in. X equal to negative 2 squared, which is gonna be equal to 4. 4 minus 4, that will be equal to 0. So I do have a first coordinate. I need more order pairs because this is not the linear equation. Okay, second one. I plug in x equal to negative 1. So I have a 1 minus 4, which is going to be negative 3. Okay, I let you guys to do rest of them. Once you're done, you could graph the equation on the graph paper. Okay, check your work. You should get negative 4. And then the rest of it is going to be negative 3 and 0. So you can see the quadratic equation will be upward. And then I have the x-intercept negative 2 and 2 when y is equal to 0. Okay, and this is gonna be my y-intercept. When x equal to 0, y will be equal to negative 4. Okay, so it looks like the U shape here. That's it.